In this section, we're going to go through applications of those linear systems. So we're really going to do two main things. We're going to first go through what are the guidelines, how do I go about solving real life problems, and then we're just going to do a bunch of examples. So we have an overall strategy anytime we're dealing with a word problem, because I know anytime you sit there and you have to apply the math, it makes it more complicated, even if it's something that's neat to see. So the very first thing you want to do is you want to go through and you want to read that problem super carefully. You want to figure out what quantities are given to you, what quantities are unknown and that you need to find. Anything that's unknown, then you're going to assign a variable. So when you're going through and writing down these problems, you really want to make sure you're signifying to the reader what each variable is representing. And use stuff that makes sense. You can always use X and Y because those are our common variables. But if you're dealing with a length, maybe you want to use an L, a volume, a V, something along that nature. You can also draw a picture if that's a little bit easier, because then you could label the different sides, like if you're dealing with like fencing or something of that nature. After you've gone through and you've assigned variables to those unknowns, you want to create two equations using those given variables and that given information. Once you have your two equations, then you're going to solve the system as normal. And then last, you want to check your answer. And by check, it doesn't mean, does this satisfy the system? More so, this is a real life problem. You want to see if it makes sense. If you're trying to find a dollar amount and you find the dollar amount is negative, not going to be possible. If you're dealing with the selling of a TV and you find out the TV is 50 cents, also doesn't seem too super reasonable. So all the answers should make sense. And so if you kind of notice that something seems way off, then it's a good indication you set the problem up incorrectly. So we have to go back and redo that system. So we're going to go through a few examples. The first one's going to be about numbers of wins and losses. So we're told during the 2013 MLB season, the Phillies played 162 games in total. They won 22 more games than they lost. How many wins and how many losses did they have? So there's really a lot of information packed in such a short sentence, or 3 in total. But we have 2 unknowns. The first unknown we'll call X, and this is going to be our number of wins. The second unknown we'll call Y, and that's our number of losses. And again, you could call this a W and you could call this an L as well if you wanted to use those variables. L's tend to get looking like ones after a bit, so just going to do X and Y. So our first piece of information is that in total, they played 162 games. And as a result of this, if we sum up the number of wins and losses, it should add to 162. So the first piece of information, we can actually create the equation that if we add the number of wins and losses, it better equal 162. The second piece of information they tell us is they won 22 more games than they lost. So they won 22 more than they lost. Okay. So really what that means is the number of wins, which is our X, is 22 more than the number of losses. So if I lost 50 games, my number of wins would be 50 plus 22 to give me 72 wins. So from here, we have our system, which we then can go through and solve in either way. So X plus Y needs to equal 162, and X is 22 plus Y. So again, I can go through whichever method I'd prefer, elimination or substitution, but because of this second equation, I can immediately plug that back in to that first equation, and that will allow us to solve for that other variable. So substitution is going to be our better method, because we have x plus y has to equal 122. Replacing that x by 22 plus y must equal that total number of games that we played, which is the 162. Okay. So we've gotten rid of one variable. Now it's a matter of solving this equation. So we have y plus y, that's really 2y. Go ahead and subtract the 22 from both sides. And so 2y is equal to 140. And then last but not least, to find y, we divide by 2. So y is equal to 70. And so I've got my one variable. Y is representing the number of losses. So in total, we have 70 losses. Okay. Now we need to find x, but again, we go back to that first substitution we had. So x is equal to 22 plus y. So our wins is 22 plus 70 for a total of 92 wins. Okay. And so again, I don't need to check my answer, but yes, this definitely seems plausible. If I add the 70 and 92 together, it gives me that total of 162 games. So this seems reasonable, and it is our answer. Let's try another example. We are running a concession stand that's selling hot dogs and sodas. Each hot dog is $1.50 and each soda is 50 cents. At the end of the night, in total, we made $78.50 and we sold 87 items. We want to figure out how many of each item did we sell. So again, I have two unknowns. The first unknown is my number of hot dogs, and my second unknown is the number of sodas. So we'll let x be the number of hot dogs we sold, and we'll let y be the number of sodas sold. Again, you can use an h and you can use an s, but s is also one of those variables that can look like a number. So I'm going to stick to my classic x and y. So let's dissect now each of the pieces of information. We're going to start with the sold 87 items. Because we sold 87 items, if I take the number of hot dogs plus the number of sodas, in total, it has to be 87. The other piece of information is at the end of the night, we made $78.50. So that is our total profit. So we've got to come up with an equation to give us a total profit of $78.50. Have those two backwards. Okay. So if I sell X hot dogs, the profit I'm going to get from them is $1.50 times the number of hot dogs. And if we sell Y sodas, we're going to get 50 cents from each of those. So I take the price and I times it by the number of that item. So this first one is the price times the number of hot dogs. And this one is the price times the number of sodas. And that gives us our total profit. So we are set. We have our system. X plus Y has to equal 87. And then 1.5x plus 0.5y needs to equal 78.50. Okay. So you can do substitution, you can do elimination. I'm going to go ahead and do elimination on this one, and I'm going to cancel out my y's. So I'm going to take this and I'm going to times it by 0.5, and I want to make that sign opposite. And in doing so, let's rewrite our system over here. That gives us negative 0.5x minus 0.5y. And if you take 87 and times it by negative 0.5, you get negative 4350. And then the second equation is completely untouched. So if we add these together, it's going to make the y's cancel out. I have 1.5x minus 0.5x. This gives us 1.0, or just 1x. And if we take 7850 and subtract 4350, it leaves us with 35. So this is really just saying x equals 35. So we sold 35 hot dogs. Okay. And now we got to figure out the number of sodas. So I'm going to go back to this first equation to figure out what y has to be. So we know x plus y needs to equal 87. We just figured out x is 35. So 35 plus y is 87. And then we subtract the 35. And that leaves us with y on the left. And 87 minus 35 gives us 52. And so remember, y is representing the number of sodas. So we sold 52 sodas. This last example is definitely going to be our hardest. So we are told we need to create a 20 milliliter solution for our chemistry class that contains 32% alcohol. But we only have 2 solutions that we can use to mix to get this concentration we want. One of them is 25%, the other is 35%. We want to figure out how many milliliters of each of these solutions do we need to combine to get this desired concentration of 32%. Now, I personally draw the same exact picture every single time I do one of these mixing problems. So I'm going to start by drawing 3 containers. So here is my first container, my second container, and my third container. We're adding 2 solutions together, and in the end, we want to get some concentration. So on the left-hand side, I want to put these 2 concentrations that we have. We're mixing 25% alcohol and 35% alcohol. And that's going to give us a solution that contains 32% alcohol. I want a solution that is 20 milliliters. So this jug is filled up so that it contains 20 milliliters. Okay. The other 2 solutions, though, I have absolutely no idea how many milliliters of each. So I'm going to call this one X milliliters, this one Y milliliters. Okay. So X is representing my 25% alcohol, Y is representing my 35%. You can write those down if you need to, but the picture is explaining which variable belongs to which. So I need to come up with 2 equations as a result of this. The first one is going to deal with the fact that I want 20 milliliters of this solution. So if I take the amount of milliliters from each jug and add them together, it better in total to 20 milliliters. So that's going to be our first equation. The second equation is a little bit harder to come up with, but if you follow this picture, it's going to be the same process each time. So this solution contains however many milliliters in total. I don't know. But because it's 25% alcohol, a quarter of those milliliters are going to be pure alcohol. Same thing over here. I might have to fill this jug up completely for my specific solution. And whatever I fill it up, 35%, which is roughly about a third of it, contains alcohol. And in the end, we have a solution that is 20 milliliters, and 32% of that is alcohol. So I'm not magically going to create any amount of alcohol. If the first solution has 10 milliliters, 25% of that is 2.5. So there's 2.5 milliliters of alcohol in that first solution. So we really are using those percentages of alcohol to come up with the second equation. So the second equation, don't need that there. I'm going to start with this last jug. And what we're going to have here is going to be the milliliters of alcohol in the 32% solution. Okay. So what I do is I take my total quantity, and 32% of that is going to be alcohol. So we're just going to times these two together. So out of those 20 milliliters, 6.4 of them are going to be pure alcohol. So we're really just taking this percentage and multiplying it by the quantity. And so we're going to do the same thing for the other solutions as well. In the first jug, this is the number of milliliters of alcohol in the 25% solution. So we take the milliliters in total of the solution, and we find 25% of it. And then same thing in the third one. This is the number of milliliters of alcohol in this 35% solution. So we take the milliliters of this solution that we have, and we find 35% of it. Okay. So every single time you're taking the percentage, timesing it by the milliliters. Percentage times the milliliters. Percentage times the milliliters. And that's how we're creating this second equation. So from here, we just need to solve the system. So rewrite our two equations. X plus y needs to equal 20. And then 0.25x plus 0.35y needs to equal 6.4. You can use elimination if you want. I personally think substitution is going to be a little bit easier because I can rearrange this equation. We just subtract x to the other side, and our y has to equal 20 minus x. So plugging that into this equation, that's 0.25x plus 0.35 times 20 minus x equals 6.4. So from here, we've got a single variable equation that we can go ahead and solve. We need to do 0.35 times 20, and then combining those, that's minus 0.35x equals 6.4. Okay. So we'll go ahead and combine our like terms. We've got 0.25x minus 0.35x. That leaves us with negative 0.1x. And if you do 0.35 times 20, that's going to give us 7, and this needs to equal 6.4. So now we go ahead and subtract 7 from both sides, and that gives us negative 0.1x is equal to negative 0.6. Go ahead and divide by negative 0.1, and you can see it works out because our negative signs cancel each other out, and I end up with a positive quantity. We end up getting x is equal to 6. Going back to our drawing, x was the concentration of 25%. So we need 6 milliliters of the 25% solution. So we're almost done. Now I need to figure out how many milliliters of 35%. But that's where we go back to our y equaling 20 minus x. So plugging in that we just found x is equal to 6, our y is equal to 14. And so we need 14 milliliters of the 35% solution. So mixing problems are definitely the hardest of these systems of equations, so take your time. But again, if you set it up with that picture, you're just doing the percentage times that variable or whatever amount of substance you have underneath.